Okay, RC, reference counting smart reference counting smart pointer. Okay, this thing can do everything a box can do. However, hold on, let me get this open here. So, fn main. Okay, so we have to include, in order to do some of the things we need to do, we have to include the standard package RC RC. Okay. Oh, I put main. I'm bugging here. Oh yeah, main. Okay. FN main. Okay. All right. So we're gonna do it the same way as we do. Let's call it M. As we do a box. Okay. RC. New. Turbofish. So we'll put 5 on it. Okay. All right. But the interesting thing is. With an RC or a reference counted smart pointer, you can clone it and it'll keep track of how many references you have. So let's go, is P equals, we'll say RC clone, and then we'll make a reference to M. That's the reference symbol, you know. People coming from the C++ will know this. Okay, and we'll print out print line. We'll put count is let's put an arrow there. It's RC strong count, and then we'll put M in there. All right, now this should come out with 2 because there's one there's one variable that has cloned this variable. Okay, so let's come up with 2. So it's a rust C. Oh, what the hell am I doing here? Okay, rust C. We'll put RC. I knew it was gonna blow up. Account it's not found in scope. I think I put this like that. Okay, importing RC, blah blah. Okay, let's see if that was it. I think that was it. Unused variable. All right, let's see what he gives us. RC vids. So okay, you can see that this is just a warning right here, but you can see that it's giving us because one other variable is pointing to it. The count is 2. It tells that there's 2. So let's see. I haven't tried this, but we'll call this F equals RC clone, and we'll clone M again. See if that gives us a 3. Okay. Okay, it's giving us 2 warnings this time. But you can see it says the count is 3. So it's keeping track of how many how many variables are lended out. Now you cannot use this with concurrency or multiprocessing. This is not, we'll get into atomic variables or ARC. That'll probably be one of the last ones that I do. But if you look at this is more like a shared pointer. Yeah, this is like a shared pointer in C++. However, it shows you with the shared pointer, you're able to edit a value, and it will change all of the value, or it will change the value for all of the It'll change the value for all of them. But if we let me just show you this. Okay, so let's RC colon make the hell they go there. Okay, make mute, and then we'll put mute. We'll put M. What the fuck? M. Then we'll plus equals 5. Okay, let me just make sure this compiles. Cannot borrow is mutable. Okay, I gotta make this mute. Okay. So okay, compiled with the 2 warnings. So now we're just gonna print this all out. All right, so first one is M, P, and F. I don't know where I'm coming up with these letters, but oh well. All right. So it compiles easily. It compiles no errors. And you can see that it only changed the first one. It doesn't change them all together like a shared pointer in C++. Well, we'll do this to another one. Let me just copy this and we'll turn put 10 there, and then we'll put P is the next variable. So, and then you can see that you can also see that it took away a reference, meaning that this leads me to believe that it's making a deep copy, meaning that it's copying the variable all over again when you do this mutable thing. Okay, I'm showing you this for a reason. So let me just do this real quick and then I'll get to my point. Okay, now you can see there's 15, but there's only one. There's only one. It's not even, it's just making a deep copy in each one of these, right? Meaning it's copying the whole variable to a new section, right? So in order to do like a shared pointer, we have to use a ref cell or a cell. I believe that's probably going to be the next video I do. Yeah, that'll be the next video I'll do because that coincides with this one right here. And we'll show you how you can, because it's kind of like, it kind of like cheats around mutability with the ref cell. So there you go.